Okay, so today we're going to take a quick look at some trig that we're going to use when we do vector analysis. And so this may be a review for many of you, and it may be brand new to some of you. So I'm just going to go through, and you can use this video as you need it. So first things I want to point out is make sure when you're doing this that your calculator is in degrees and not radians. Okay, you have to be in degrees. So really quickly here we have a right triangle. And we have this angle here, which is called theta. Okay, so if I want to know the ratios of these sides to theta, I can use what's called SOHCAHTOA. Okay, so again, here's my angle theta, and if I look across from that angle, I'm going to have my opposite side, which doesn't touch the angle, it is across from it. The hypotenuse is always going to be across from your 90-degree angle, and then the adjacent is going to run into your angle that you're talking about. So you see that it runs into your angle theta. So does the hypotenuse, but it is across from your 90-degree angle, and your opposite side does not touch the angle you're talking about at all. Okay, so this word SOHCAHTOA is a way of remembering how to solve for these sides. So I have SOHCAHTOA. The S here stands for sine. Okay, so if I take the sine of theta, it is equal to OH. That is your opposite divided by your hypotenuse. Okay, so your sine of your angle is equal to your opposite divided by your hypotenuse. The K stands for cosine, and so the cosine of theta is equal to AH, your adjacent divided by your hypotenuse. And the last one, TOA, your tangent, is equal to OA, your opposite over adjacent. Okay. All right, so now we're going to have a little practice here. So we have two different triangles. We're going to concentrate on this one first. So I see that I've got this angle here of 25 degrees, and I know that I have this side here of 7 centimeters, and I know it's a right triangle. So the first thing I'm going to do is identify what my sides are. So if I look over here, going across right here to this side, this is opposite of that angle. So this is my opposite side. Here's my 90-degree angle. If I go across from that, that's going to be my hypotenuse. And that means the only one left is what's going to run into my angle here, and that's going to be my adjacent. Okay. The next thing I'm going to do is I'm going to identify what the angle is here. The sides have to add up to be 180 degrees. So if I have 90 degrees and 25 degrees to find out what this angle is, 90 minus 25, and that's going to give me 65 degrees. Okay. So now I want to find out what this side over here is. So if I want to know the opposite side, and I have the adjacent and this angle here, I'm going to use my tangent. Okay, so I have my tangent function, opposite divided by adjacent. So opposite divided by adjacent. So now I'm just going to plug in what I know. I know that the angle theta is 25 degrees. I don't know what the opposite is, but I do know the adjacent is 7 degrees. So I'm going to plug that in. So I'm going to have the tangent of 25 is the opposite divided by 7 centimeters. I have, excuse me, I have to multiply both sides by 7 centimeters. And when I do that, I'm going to get the opposite is 7 times the tangent of 25. And as long as I'm in degrees, if I work that out, I'm going to get 3.26 centimeters. Okay. So now I have this side, and now I want to get what the hypotenuse is. Because I was given this side, I'm going to use this. So I'm going to use adjacent and hypotenuse. And I should recall back that adjacent over hypotenuse is going to be my cosine. So once again, I'm at the cosine of theta, and that's going to be my angle I have here. And so I'm going to say cosine of 25 equals the adjacent of 7 divided by the hypotenuse. And now it's just a matter of doing the algebra of knowing that I multiply both sides by the hypotenuse and then divide by the cosine of 25. So I'll get the hypotenuse is equal to 7 divided by the cosine of 25. And then if I work that out, I'm going to get 7.7 centimeters. Okay, so I've gotten all the information for this triangle over here. Now this one over here is a little bit different. It is a right triangle, so I can use my SOHCAHTOA. but I don't know what these angles are. And so when I do this, I'm going to concentrate on this angle right here. So I'm just going to come right here and say, what is this angle? And I'm going to call that theta. Okay. And then I'm going to go ahead and I'm going to identify again. So if this is theta, going across from theta, this over here is going to be my opposite. This going across from my 90-degree angle is going to be my hypotenuse, and then my angle or my side that runs into my angle is going to be my adjacent. Okay, so now I know these terms here. And I'm going to go ahead right now, and before I even get the angle, because that is the tougher thing to do, I'm going to try to remember back to Pythagorean theorem. If I know two sides, any two sides, I can get the third side using a squared plus b squared equals c squared. Now, I changed those letters to match what I have here. So instead of a squared plus b squared equals c squared, I'm going to say a squared plus o squared equals h squared. And I know that's probably a little bit confusing, but that's the way I kind of wrote it out, just so that we can kind of use our opposite adjacent hypotenuse writing there. Okay, so I want to know the A. I want to know my adjacent side. I know my opposite and I know my hypotenuse, so now I just fill in my numbers. So I'm going to say a squared equals my hypotenuse squared minus my opposite side squared, and then plug in the numbers, and I'll have 20,000 squared minus 8,000 squared. And then to get a, because it's a squared here, to get a, I take the square root of my hypotenuse squared minus my opposite squared. And if I do that out, I come up with 18,330 meters. Okay, so now I know all three sides. The angle is a little bit tougher. So here, I want to know this angle right here. Now, I was given the opposite and the hypotenuse, so I'm going to use that. And if I remember back, the function that gives me opposite over hypotenuse, that is my sine function. So I'm going to say the sine of theta is equal to the opposite over the hypotenuse. Now I'm trying to find what theta is. I know both of these, so I'm going to plug those in. I'm going to say this. Okay, so I've got my sine theta equals 8,000 over 20,000, my opposite over my hypotenuse. And then I'm going to come over here and I'm going to say, well, just theta. Theta is going to be equal to the inverse sine of 8,000 divided by 20,000. Now you should see this symbol on your calculator. If you're using my kind of cheapo calculators, you have to hit shift and then sine to get that. But you should see that symbol on there. And so you do the 8,000 divided by 20,000, get the inverse sine of that. And when you do that, you come up with 23.6 degrees. In order to get this final angle over here, I would just do 90 minus 23.6, and I would get my final angle. So that's how you get all the information for the triangle. Okay, so now we're going to apply this to vectors. So over here, I've got my coordinate system right here, and it says a vector of 32 meters, 30 degrees north of the horizontal. So recall that a vector needs direction and magnitude. So my magnitude is 32 meters. My direction is 30 degrees north of the horizontal. So I'm going to pull in a vector over here. I'm going to start it right over here. Now, 30 degrees north of the horizontal. Here's the horizontal. 30 degrees north of that, I'm going to say is about that. And for right now, we're just going to estimate it. Okay, so there is my vector that is 32 meters, and it's 30 degrees north of the horizontal. Now to figure out what the x and the y component is, so I'm going to pull in my x component for that vector, and or my y, sorry, and I'm going to pull in my x component over here. And so that is what it would look like for the x and for the y. So again, this angle here is 30 degrees. So if I want to know what my x and my y components are, so here is my x and here is my y. And again, this angle right here is 30 degrees. So recall that x is going to be, if I want this right here, this is my adjacent side, and this is my hypotenuse. So the vector is going to be your hypotenuse. okay? And so if I want to know my x, and I'm given my hypotenuse, remember that that is 32 meters. So I have my hypotenuse, and I want to know my adjacent side. That's my cosine function. So I'm going to say the cosine of my angle of 30 degrees. Sorry about my terrible drawing here. The cosine of 30 degrees is equal to the adjacent divided by the hypotenuse. So the adjacent I'm just going to call x divided by the hypotenuse of 32. Okay, so then when I do my algebra here, I'm going to multiply both sides by 32. So it's going to be 32 times the cosine of 30 is equal to x. Well, if I do that out, I'm going to say 30 cosine times 32 equals, I get 27.7 is my x component of that vector. Now to get my y component, now look where y is, it is opposite. So I'll do a different color here for that one. So to get y, I'm going to say the sine of theta, which is 30 degrees. So the sine of 30 degrees is equal to the opposite, which I don't know, that's my y, divided by my hypotenuse, which is 32. So once again, for this one, when I do the algebra, I'm going to multiply both sides by 32. And if I do that out, I'm going to get 16 meters. Okay, so that's how I got my y component and my x component. So once again, I'm going to do another one with you right here. So this one is written a little bit differently. 55 newtons, 30 degrees to the right of the vertical. So here is my vector that I'm going to pull in, okay? And it is 30 degrees to the right of the vertical. So here's the vertical. So 30 degrees to the right is going to be something like that. Okay, so there is my angle of 30 degrees there. So now when I pull in my x, it's a little bit shorter than that, and my y components, oops, sorry, I'll get this over here. Oh gosh. Close enough, almost. There we go. Okay, so now I have my x and my y here. The tricky part of this is that I just told you that this right here is 30 degrees. That means that this angle here is 60 degrees. Okay, so be careful with things like that. If it's 30 degrees to the right of the vertical, then when I make my triangle here for my x and my y to get the component vectors, this angle here is 60. So I'm just going to kind of cross this out right now and put a 60 degrees here so I don't mess this up as I go forward. And then recall that the 55 newtons, that is this vector right here. So that is equal to 55. So now, once again, if I want to know my x, I use this color for x. Here is my x. Once again, it is my adjacent side here, and this is my hypotenuse. And so we're going to say the cosine of 60 is equal to the adjacent, which I don't know, over the hypotenuse, which is 55. Once again, doing my algebra, 55 times cosine of 60 would give me my answer. If I do that times 55, I get 27.5. And that was newtons. And then if I want my y, again, my y is going to be opposite of that angle. That's going to be my sine function. So I have sine of 60 is equal to the opposite, which is my y, divided by 55. And if I do that, and then I'm going to multiply both sides by 55. So when I do that, I'm going to get 60 sine times, I'm going to get 47.6 newtons. Okay, so hopefully that helps and gives you a good starting point to do the practice parallelogram sheet that I have for you, the trig sheet that I have for you.